Welcome back to Chapter 12. This is the last video for Chapter 12. And in this video, we're going to start with working with multiple files. Now, when it comes to working with multiple files, it's pretty common. It's expected that at times you'll be opening a file to read from while opening a file to write from, or maybe you're reading from multiple files and putting the data into one file, or you're splitting data across multiple files. So it is pretty common to expect that you're going to be working with multiple files. So you can have more than one file open at a time in a program. Of course, each item is going to have its own I/O stream. So each object will have its own file stream. And you can open the files with input or output. This is where using a function to do your one item for each item gets to be real handy. Now in this, we can see that we have that stream and that stream. We know that this is going to be an input stream and that's going to be an output stream. And in here, they're opening this file, which they are specifying that it's going to be an in file. And then you can see that they are checking to make sure that it opens successfully. That's what this line is doing. It, by the way, while this does work, I do want to tell you that it does not catch all the issues. So there are better ways to check to make sure that everything is open and ready to go. So you may want to make sure that you're doing that. And then we're going to get a char from the input stream. This is known as that loop priming. And then we sit in this while loop and we output the character. Then we read another character in and do it all again until we get to the end of the file. Always remember that we must close our files. Very important. Again, I'm going to put a star by this because this is how people lose points. And because they want to be nice, if this check does not work, then they're going to output that the file was not able to be opened. This is the output for the file we were just looking at. Next up, let's talk a little bit about binary files. Now, so far we've been outputting actual characters to a file. With binary files, we're now putting out zeros and ones to a file. Why might we want to do that? Well, there's a couple of good reasons. Now, first off, we can just put standard text in a binary file, but oftentimes we want to use a binary file to do certain things, maybe save an image. How about we want to output data, but we want to keep structure too. Now, by the way, so binary files have kind of been the go-to for this. There are some other ways now that are getting to be a little bit more popular, like using JSON, but that's okay. We're going to stick to binary files at the time for the time being. So remember, binary files contain that unformatted, non-ASCII data. It's just like we talked about. It's a bunch of ones and zeros. You can indicate that you want to output using binary by doing the flag iOS binary. Now remember, you got to have this pipe. If you don't have this pipe, then it will not bring these two together, these two flags together. So when we talk about binary files, we use read and write instead of these operators. So we say in file, which is obviously our stream, dot read. This is the address of where to put the data being read in. The read function expects to read chars. How many bytes to read from the file? And so this is going to be the size, or again, how many characters. Similar, when we do write, we're going to give the address of where the data is and how much of that data to write. To read, write non-character data, you must use a typecast operator to treat the address of the data as a character address. So we've been doing casting, and as I've told you in the past, there are different types of cast. This is a new one, and so we've got this reinterpret cast of a char pointer. So here, it's just like before. We are now just doing this cast. Now we're just doing this cast, and we still have the size of. And same thing with write. So now I'm sure at this point you're like, Professor Waits, that's all good and fine, but really, why? Why do we want to do that? What's some of the benefit of that? And I know you kind of mentioned it before, but I don't see it. I don't understand. So show me something that makes sense with binary. So let's talk about outputting structures. We talked about structures in the last chapter. Now, and think about structures. Structures kind of represent or resemble a record of data. So, with that being said, how could we use this? Well, when we want to work with structs and files, we're going to use that binary, and we're going to use read and write to do such. So first, we got to have a struct. There's our struct. Then we need to create a version of that struct. So, and remember, a struct just describes what it is. This is us actually making an object of this struct. So this uses this as a template to make an actual object. And now we're going to write out that. Here we got the write. We're going to reinterpret cast to a char pointer. We are going to give it the address of the one test. And then, because we want to output the entire struct, we're going to actually use one test as the parameter to size of. So this will say, look at the entire struct. Tell the write how big it is. Now, interestingly enough, in this PowerPoint, they don't really talk about reading data in to a struct. So I will tell you that it's very similar to this. And if you are interested, there is information all over the place on how to do it. And I'm thinking I might even make a video on how to do it. So random access files. What is a random access file? Well, so far we've been talking about when we read and write to a file that we've been doing it in order from beginning of the file to the end of the file. What if we want to grab data from the middle of the file? So we've been doing sequential access, which is where you start at the beginning of the file and you go till you hit the end of the file in order. So to access the 100th entry in the file, you have to go through 99 preceding entries first to get to that 100th character. Well, if we have random access, we could tell our file pointer to go to the 100th entry directly. To do that, we got to get familiar with seek G, or known as seek get. Used with files, this is how you open. Used with files open for input, and seek put is used with files to open for output. Now, I will tell you that sometimes people get this confused. There are terms as known as get, and there's also a term called peek. And so sometimes people confuse this P with peek, and that is not what's going on here. So that is nope. That is seek put. And that's used with files that are open for output. And this is used to go to specific points in a file. So how do we use that seek G and seek P? The arguments are the offset, the number of bytes as along, the mode flag, starting point to compute offset. So here we have the seek G. We are telling it the offset is 25 bytes long, and we're telling it that this is where we're going to begin, as we said here. So we're setting the reposition at the 26th byte and from the beginning of the line. This one is saying set the right position to the negative, position to 10 bytes. And that's before the current position. Whoa, wait up. Wait a second. Professor Waits, why was that number negative? Well, let's go back and take a look. That's because we want to start at the current position, which they are saying wherever this cursor was, right? So we have our little cursor, and go back 10 spots. Oftentimes what happens is when you open a file, you may want to say something like -20 iOS dot end. I think it's end. Let's see. I think it's end. And so that says, hey, start at the end of the file and go back 20 spaces. So again, the negative is going to make it go that direction, where positive obviously goes that direction. So if the end of file is true, it must be cleared before you use the seek G and seek P, or seek get and seek put. And we've talked about how to clear that before. So make sure you clear that if you accidentally hit the end of file. And one way, by the way, to clear all the flags is that you can hit the clear, do the clear. And that, by the way, clears all the flags. And so here we have the seek get starting from 0, or grabbing 0. So that says go to the beginning of the file with the iOS begin. So you're going to literally go to the 0 spot at the beginning of the file. That starts from the beginning of the file. TellG member function returns the current byte position in the input file. So, because it is going to come back to you as a long int, you need to specify a long int variable. Where am I is that variable, and the TellG is going to put in that variable as a long int the position in bytes. All right. So now let's talk about opening a file for both input and output. This seems pretty straightforward. In fact, probably along the way kind of figured out how to do that, but let's just talk about it. Files can be opened for input and output simultaneously. Makes sense, so we can read from a file and output to it. We can read data from file into memory, update data, and write data back to the file. So we're going to use fstream. Now remember, we've been using iStream and OStream for input and output. The fstream is exactly for both. It can do both. And now we're going to specify this is the variable name, the stream name, the name of the file, and we're going to use this pipe and say both iOS in and iOS out. Again, don't forget that pipe. That's a pretty common mistake, by the way. You can also use the iOS binary flag for binary data. Now, you would think that as well as this chapter has done in giving examples, they would give an example, but the PowerPoint doesn't. But it is as similar as all the other file inputs and outputs we've done. Again, in this case, we're using the fstream, and we're using the binary with the iostream in and iostream out flags to represent that data. And then we're going to use this name that the grade list, and we're going to use the common functions that we've been using, the read and the write pieces to read and write. We can use the other file operators as well with this stream. All right, so this is the end of this chapter. If you have any questions or concerns, please make sure to send me an email. Try to be specific with your issue so that way I can help you. And if you are struggling with any of the thoughts on any of these videos, make sure you watch the video a second time. Oftentimes, I hear from students that when they watch the video a second time, they pick up things that they didn't pick up the first time. And keep an eye out. Like I said, I'm going to create another video in a day or two that will go through some of examples on some of the different types of files and how we may do things, especially reading and writing structs and so forth. Until then, I hope you have a great day, and we'll talk to you soon.